Hello Earth, welcome to episode 28 of season 2 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time and you want to know what this is about, please go to github.com/autocodenl/cell, link in the description. We're going to continue where we left off at a very interesting spot. Sorry, wait a sec. Yep. So yeah, I'm back. So this is what we have next. We already yesterday, last session, which was yesterday, we implemented a reference, and we had the tests for them as well, which is very cool. So a few ideas I want to share with you. Of what comes next, for example, is I want to be able to write a function inside an if. For example, something like this. If I don't know, the condition would be something, then just do some stuff. Do is going to be the operator to define a function or a call, really, but actually the name is neither function or call. The name is sequence. However, instead of defining it, what we can do here is actually just execute it, and that's super cool. You cannot do that in JavaScript. You cannot do if actually you could do it like this, and then you would do you would, I guess, yeah, you could just put arbitrary code here, or you could wrap it in a immediately executing function. But this if doesn't have the proper scope of a function unless you wrap it inside a function. So I like this. I like it to have it in a lambda, basically. Sequence in the then or else, and we're going to implement this very soon. But now we need indirect reference, I think, because we now have regular references, right? Yeah, I think we do. We have this, so yeah, this gives us the possibility of setting a reference anywhere, and we're basically going to walk up, and this is going to be expanded to equal. I do have a question about, I was thinking about the branches of things, because right now you would basically have three paths here: foo, and then reffoo that has an equal, and the reffoo has an add. So in this case, it's not a problem. I think yeah. So I think when you have multiple references on the same path, that's gonna generate issues. Actually, you know what? Let's implement it and find out the issues in the way. But I felt that there should be like a turn off of one. Like, not all paths should be continually expanding things. What if you have an equal to the left of an add? That was my intuitive doubt. But you know what? Let's just implement this. All right, just a minute. All right, so how would be an indirect reference? Let's just let's start with a list that has two elements, right? Well, what would be an indirect reference? It's like I want to use one value to give me another value. So list gives me foo, or let's say bar. I am thinking of writing this entire test suite with nice words from Shakespeare and literature, and I would like go to the opposite extreme of doing everything with foo. The opposite of Liskov what's it? Liskov substitution. The exact opposite of that. So I have so I want to get, so foo would be 1, And then I want to put reffoo should be equal to list. Okay, this is foo, and this should give me bar. Of course, it's not gonna work. Yes, this is the double thing I was thinking. So what am I expecting? I'm expecting list. So foo one list one bar, then expecting a ref at. Actually, let's write it down what we expect. Reffoo at list add foo, and this should expand to, well, this foo will expand to, actually the way to do it would be like this, right? And then that would give me yeah. So that would give me list one would give me bar. Yeah, that's what I want. So here I have a path with at and at. So if there's a path with at and at, it would be list foo becomes so what would be the logic here? Well, I guess we can write down reffoo equals bar, that's one. Equals bar reffoo. I'm starting to develop an intuition for these things. I think I'm starting to get it. List equals, so the results. One. It's pretty cool. It's pretty cool. List at what was it? Foo, right? Yeah. So this is what I'm expecting. And we are actually are we quite close? So we're missing this one, and these two are just plain wrong. So let's just look at what's going on here. Actually, before we even look at the code, what would it be? So I find a path with an at. So I find the last at. So then what I do is I decide what the equal should be for it. In this case, step 1 becomes reffoo adds list equals 1. This one we have, right? This gives you because do we have that in the example? Yeah, list at foo, yeah. Or at least at foo, yeah. Oops. Yeah. Why is it gone? It's not gone. It's just gets this equal there, which is wrong. But this is the one that should be here already. So if I go first, it's just 3 paths, right? Or 4? Yeah, just 3. If there's a call, there's 2. If there's 2 calls, there's 3. So okay, let's look at the logic then. There's a rightmost one. We find out what its equal should be. We compute it. And if it's not equal to what we have, we set it. Good. Now, let's say we do that. Then we have so we have these two. Now we need to leave the bottom one untouched on step 2. If the values match, go to the previous at, and then do the expansion. That should be it. So we'll remove this. So while there's an at, what's the opposite of push? Don't tell me it's lies. Pop, of course, I forgot. So if there's equality here, we would do continue, right? Otherwise we do all the updates. We return that breaks things. Yeah, this will work. Okay, add. No. To this one. No. All right. We're still where we were before. We're 4, 1, 2, 3, 4, correct, and then 2. Ah, there's an extra slice here, right? Okay, so it's putting now reffoo equals honestly let's just rename things a bit. Okay, so it starts with indirect. Yeah, setting, this is the correct one. And now why doesn't it put anything here? Ah, because it's not doing the proper, of course, because I'm not jumping the equals, right? We have to change the logic of, I think, get, right? Yeah. getting from foo, and here we're getting from list equals 1. So what we need to do here is we need to chop off this equal, right? And I think we can even do it here. So when this is always going to be in the middle. Yeah, basically we need to jump over equals, right? Like we said. Yeah. Let's try it. I am not fully convinced. I would only jump over an equal if there's a path that has that an at below it. Otherwise I wouldn't jump over the equal. Well, we know there's an at here, and there's an equal. I think we could just remove all the equals. If not, we can find the corner case later and add a test and fix this by doing a lookup. But now I think we're okay. We don't need to do a lookup. We can do this. We need to. Uh-oh. It expands forever. It's putting p indirect equal. No, wait. No, I should slice the other one, right? So I don't slice filter. No, I need to jump over the equals. Sorry, the equals. When I'm doing when, because here I'm not jumping over any equals. I would just do this is 1. Here, when I do this reffoo add list equals 1, yes, if there's an at, then remove all the equals. So remove all the equals that are to the right of the at. But remove them when? Remove them To set or to get? To do the get of the actual value, that the actual value you need. It's in the current value. That's correct. I want to get oops. So everything here is I think this is correct. Because all the one to gets, if they have equals, they shouldn't have them. It's least one. The question is why it keeps on going. Putting in why there's no value. It's not finding one thing. Why didn't it stop? Why doesn't it stop? I guess that. Yep. Oh, come on. Uh, how can it always be 10? I don't get this. Because it's calling put. Put is so it shouldn't do this, right? If put calls cell response, then there's no need to do that recursive call. We're almost there. At least at foo is the original one. That's what we want. That's what we want. And then this is also correct, right? Yeah, it's also correct. This. If we can do something like if I do that, just one. They she last, where if it already finishes with equal, that won't work either. Yeah, we're gonna have undefined. This should be p concat if they she last. No, I want to do it here. Not very clear. Why suddenly we have only one? I mean, one indirect. I mean, I have the result, but what's going on with the other ones? Why? Because not everyone that has equal. It's a double equal. is equal. Give paths to put 0. No, it's equal, not at. We're almost there. It's just the sorting. No, never mind. Because paths to put. Sorry, no, they're not characters. Of course, they're. So, what's going on? Why is the put? Because the put is completely overwriting, right? I'm setting indirect to equals bar, and that overrides. I need I need to I need some sort of put that doesn't override, like a put that pushes. We need a put that pushes. How would that work? It would be one that basically only overrides. Right? That's the problem. No, wait, that's not the problem at all. I should not be popping anything, right? Isn't it equal? Equal. Let's look at the result. No, it shouldn't override anything. I'm setting reffoo equals to var, right? That's just correct. Indirect equals list equals to 1. The indirect equals to I'm setting indirect equals to var. I need to respect the at. How am I going to respect the at? It's okay that there's two puts. So it's P indirect. How much nicer it looks in Java, in for data or cell, huh? So I'm setting indirect equals. Why equals? Equals at. That's wrong, right? The one that should be indirect at list equals. Why is there an equal here? This is wrong. That's a good way to put it. The actual put calls, we see it as data. Yeah. Nice. So we do that. P indirect at list equals. And then we do indirect equals to bar. So why is this put wrong here? This popping is okay, but we need to do something else here. Why am I using this path here? Why is it equal? Where's this equal coming from? That's what I don't understand. Okay, we start here, perfect. Yeah, this is wrong already, right? Why is there an equal there? Did I write it wrong here? Oh my, I did it wrong, right here. Ah. That was the problem. I was putting an equal there where I shouldn't. Was that the problem? Yeah, what's the problem? Nice. I guess equal. Well, it passed. Wow, do we really have indirect? Yes. Let's do another one with a hash. So we will do with a hash. So we would be putting ref to at foo at aqualung, and then I would get aqualung rate there. And then ref would be the equal would be 100, and then the at would be the at. I love that you have the, let's say, the formula here, and then the result at the top level, and then all the levels in the middle. I'm gonna write it down. I really like it. I think it's right. It will work. So ref at foo equals no, I did the reference wrong. It should be great, right? Let's fix it. Oh no, I have to do add great, not aqualung. Right? No, sorry. Sorry, aqualung is great, and then full grade, exactly. I mean, instead of full, maybe I can do score grade. And then I will have to move. You know what? Let's just run them and see them. Yes. Oh, this is great. It makes absolute sense. Well, at least to me. There. Okay, and I'm going to do now something I don't want to do, but I need to do, because it's good, which is comment the changes, annotate the changes. This is very necessary. cell respond. See, there's already no call to it. Yeah. And I'm not going to validate this. We call cell response in case something needs to be, some reference needs to be updated. If cell response finds that changes should happen, it will call put. In that way, cell put and cell and call. I never thought about how confusing that is, cell or call. Well, actually, it's not so confusing because it's one is pronounced cell and the other is call. So it's same letter, lexicographically or graphically, but different sound. And cell respond will call each other recursively until all the changes are propagated. And now we are going to do the annotated one. We now define cell respond, a function that will be called by cell put when an update takes place. This function, how do I say it? Expands calls to show the responses. That is, it takes the response to any calls and puts them in the data space. I want to make a note on validation there. So what do I need to do now? Yeah, I wanted to do that. We don't validate the data space after calling cell respond because there no expansion. The call should generate an incorrect results. Any call is in terms of producing every call defines a hash because add is text. So putting equal on the same prefix will not change the type of the prefix. Do we call the sorter here? No. Ah, but put calls a sorter. Yeah, so we don't have to do that at all. Yeah. Perfect. Oh, actually, that's stupid what I said, because if respond calls put, yeah, the recursive one could return an error. I don't think it will ever happen that an internal call, a recursive call, will return an error. Only outermost calls. It should be okay. Because of this, the call to from inside cell respond doesn't check for errors returned by cell put. Boom. Interesting, huh? I didn't expect that recursive call between two functions. This function takes 3 arguments. Sorry, we don't need put here at all. Why do we use put here? And the limit also can be gone completely. Nice. Yeah, data space. Yeah, sure. And then what? Yeah, it's okay. We do need a recursive function on paths. The outermost structure of the function is a loop that goes over each path on the data space and stops at the first change it finds. We will use true to signal that a change has happened as our way to stop. We find the indexes of all paths, the steps that are equal to add in the path. If there are none, we ignore this path and keep on going. We will work on the paths right to left. Start a while loop. loop? Yeah, we do. I guess we could do, instead of a while, we could do a functional equivalent, but it's okay. Let's just be traditional for a bit and do a while. We get the rightmost index, the index of the rightmost add, and remove it from the list of adds. Of the list, we know, you know what list I'm talking about if you're reading this. We set a query path to be everything to the left of the rightmost adds, to be the prefix everything to the left of the rightmost add. Perfect. Nice, 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 nice. We get the previous value, or should I say current, of the query path concatenating the query path plus equal, plus an equal. We get the current, or should I say desired future, of the query path. No, it's not the query path at all. Of the suffix everything to the right, of the at, note we remove any equals from this path. This will be our query path. You know what? What's the query path? Why am I using the query path as a current path there? Oh yeah, because it's really what it's referencing. That's why. Because everything to the right is oh, that's subtle. Oh, that's subtle. Okay, so now a tricky thing. the query path, the context path for this call to get will come, we pass that to get, for cell get. The context path for this call to get will come from, will be our query path. This is a bit mind-bending, but it makes sense. We want the reference that is after the add to be resolved in the context of query path. The reason we remove equals why do we remove equals? And we're like, that's a skipping over, right? If query path match index of oh come on, it was working. I passed the put because I need the put there. It's a bit silly passing this get and this put everywhere, right? Yeah, I agree. Wait, removing. Right, I'm never removing that. So I'm not removing, I'm concatenating. Oof. It would be oh yeah, it's that one, sorry. It would be path slice rightmost add plus 1. It's just to jump over, basically. Its path is that we want to jump over any equals to get the result of something. This is necessary for indirect references. Two arguments and put, which is the same, but for updating the data space. Yeah. If the existing value and the desired value, actually that's much better than previous. Actually, even better. Let's do current. Nice. And continue. Skip this element, this step of the path is add and restart at the top of the while loop. Right. All right, I'm gonna take a break. I'll be back in a bit. All right, I am back. Where were we? Here. Can close all of these. Yeah, I was commenting. Yeah. So, what are we doing? Yeah, if we are here, we are going to call cellput with the updated, the desired. More than desired, it should be updated. No, it's not. More than desired should be new or latest, updated. No. This is desired. I'm not sure about it, but I think I have a bigger fish to fry. We start by creating a variable paths to put. Start with one that and place inside it one path with p, the path. We set it to be the query path plus an equal sign, since that's where we want to store the value. Oof, I'm more tired than I thought because a few hours have elapsed. Actually, not a few hours, just 1 hour, but still. One hour, no, 2 hours. Yeah. So what do I do now? So basically, if the path so I wonder, can I not do this in a better way? This is so clunky what I did here. Can't I do something like if query path and then I would do comment this out. Something like this. Yeah, of course. Seriously. Then I can just do it like this. Push. As you can see, I'm simplifying everything because it's just too much. Honestly, I could do it like this. Yeah. No, because then I will have to spread. No. I6, baby. Let's just do it in the right order. Come on. So I have the equal there. Yeah, like this. So we push from there. Okay, I think this is better. So we start by determining where these new values will be set in the query path ended with an equal. However, the query if path already ends with equal, we don't append one. We create paths to put with paths that we will pass through output. Yeah. Nice. We iterate the paths in desired value per append them with P and add them to paths to push. Oh no, I can't deny. We call put, so put with a context path of an empty context path. And we then return true to stop the iteration. This closes the while, the outer loop, and the function. Nice, so we have it. All right. So, are we done? Are we done? Are we done? Are we done? We are. This. So let's just do a bit of the condition now. But before, I have a server here. What if I do this? I will do something like put before bar. Whoops. Cell parser is not a function. Uh-oh. It's parse, right? Uh-oh, I renamed everything. So the data space would be text to paths, right? Ah, because I had deleted the parsing function. So if I go with city, why doesn't it work? Oh, did I break everything? That's annoying. Yeah. No, it's not just, it's well, maybe text to paths. Yeah, that was it. It depresses me that the search doesn't work. So if I do put full bar, okay, there we're good. Now we do copy of foo. Sorry, that's not what I want to do. Sorry. Put the copy of foo. It works. And if I would do something like I would do something like put I would have something like bar is 1 and yip is 2, and then I would do something like super would be, sorry, super would be unsick 4. It didn't work, did it? What am I missing? This foo should resolve to bar. Interesting. This is not working and it should work. Okay, so tomorrow we'll fix that. Non-evolved, non-expanded. What if I something else? No. Okay, suddenly the expansions are not working anymore. That is weird. Well, but why does it work once? We'll figure out next time, but the conditional is going to be very fun. Let's just have a sneak peek. If cond, then else, and the then and the else are optional, and you can put a sequence next to them, but for now we'll just do references. The execution is defined inside a conditional. Okay, I'll see you next session. Thank you for watching.